Every number has a job. One let us count, two let us compare, and fractions let us describe part of a whole. Negative numbers let us move in the opposite direction. Even irrational numbers like pi, square root of 2 add to place. Every number seems to fit somewhere, except 0. At first, 0 seems almost boring. It doesn't make numbers bigger, it doesn't make them smaller, and it just sits there, quiet, unnoticed. But don't let that simplicity fool you, because hidden inside that tiny symbol is one of the most deepest ideas in all of mathematics. 0 behaves perfectly well until you actually ask it to do one particular thing. And the moment you do, everything changes. Not just the answers, the rules, the logic, the entire mathematical system. Some people think mathematicians simply invented a rule that says you are not allowed to divide by 0, as if it were a sign on a locked door that says do not enter. But that is not what is happening. The truth is far more interesting. Mathematicians didn't ban division by 0 because they wanted to, they banned it because mathematics itself leaves no choice. Even if we ignore that rule for a moment, the consequences would spread through every equation ever written. Algebra will stop making sense, geometry will lose its certainty, and physics will no longer trust its own equation. Even computers and machines that perform billions of calculations every second are built around that assumption that this operation is impossible. So how can one number, a number that children learn before they even start school, hold so much power? What makes 0 so different from every other number? And why does asking it to do one seemingly innocent calculation threaten the logical foundation of mathematics itself? To answer that question, one needs to stop thinking of 0 as nothing. Because despite what it seems, 0 isn't empty. It is one of the most important inventions humanity has ever made. And understanding why is the first step toward understanding why it refuses to break the rules. If I ask you what is 0, you probably say nothing, and honestly, that is exactly what most people are taught. But that answer hides something important. 0 is not nothing. 0 is the amount of nothing. That might actually sound like a wordplay, but it is the reason mathematics treat 0 as a real number instead of simply ignoring it. Imagine you're holding 5 apples. You can count them 1, 2, 3, 4, 5. Now imagine giving every single apple away. Now, how many apples do you have left? No, that none is 0. Notice what happened. The apples disappeared, but the question didn't. How many apples do you have? Still have an answer. That answer is 0. 0 isn't an absence of mathematics. It is the mathematical quantity. A quantity that tells us exactly how much is left. And because it is a quantity, it behaves just like every other number. You can compare it, you can place it on a number line, you can even use it in equations. In fact, 0 has a very special property. Let's start with addition. Take any number. 7, add 0, nothing changes. 12, add 0, still 12. A million plus 0, still a million. 0 doesn't change a number when you add it. Mathematicians call this additive identity. It is the only number that leaves everything exactly as it was. Imagine walking 10 meters forward. Now, imagine walking 0 more meters. Where are you? Exactly where you were. Adding 0 is like taking no extra steps. Nothing mysterious is happening. Now, let's try multiplication. At first, this feels stranger. 5 times 0 is 0. 100 times 0 is still 0. A billion times 0 still is 0. Why? Think of mathematics as repeating groups. 3 times 4 means 3 groups of 4. So, what does 3 times 0 mean? 3 groups with nothing inside each group. No matter how many groups you have, if every group contains nothing, you still end up with nothing. Again, nothing is broken. Everything is perfectly consistent. So far, 0 has behaved beautifully. It quietly follows every rule. It doesn't create contradiction. It doesn't confuse mathematics. If anything, it's one of the most well-behaved numbers we have. So then, why does everything suddenly fall apart the moment we try to divide it? The answer isn't hidden inside 0. It is hidden inside what division really means. Because despite how we learn it in school, division isn't about splitting things apart. At its heart, division is something much deeper. And once we understand that, the mystery of 0 begins to unravel. When we first learn division in school, it is usually explained with pizza or chocolate bars, 12 cookies shared between 4 children, each child gets 3. Simple, but that picture, while useful, isn't what division really is. It is only a way of visualizing it. To understand why 0 breaks everything, we have to look deeper. Imagine I write this equation 4 times 3 equals 12. Nothing surprising. Now, let me ask you a different question. Instead of multiplying, suppose I erase one of the numbers. Now, the equation becomes unknown times 3, which is equals 12. So, what is the missing number? It's 4. You didn't really divide. You erased multiplication. That is what division really is. Every division problem is secretly asking the same question. What number when multiplied by this number gives the original? For example, 20 divided by 5 isn't just 20 split into 5 groups. It's asking what number multiplied by 5 equals 20. The answer is 4, because 4 times 5 is 20. Now let's try another. 35 divided by 7 becomes what number multiplied by 7 equals 35? 5. Again, division simply undo multiplication. It's like watching a movie in reverse. Multiplication builds the result. Division tries to uncover what was there before, and that is why multiplication and division are called inverse operation. Each one's undo the other, just like addition and subtraction. If I walk 5 meters forward, then 5 meters backward, I'm back where I started. If I multiply by 4, then divide by 4, I'm back where I started. Everything is perfectly reversible. At least, it seems that way, because there is one number that refuses to play by this rule. Let's ask a slightly different question. Instead, 12 divided by 3. Let's try 12 divided by 0. Using our new understanding of division, we are really asking what number multiplied by 0 equals 12. That sounds like an ordinary question, but in the next scene, we are going to discover that this single sentence is a problem so deep that it forces mathematicians into a corner with only one possible answer, and that answer is there is no answer. Let's go back to the question we ended with. What is 12 divided by 0? Using what we've learned, this isn't really a division problem anymore. It is a multiplication problem in disguise. So we're asking what number multiplied by 0 gives 12. So let's start guessing. Could the answer be 1? Well, 1 times 0 is 0, not 12. Then how about 10? 10 times 0 is 0, still 0. Maybe a million. 1 million times 0 is still 0. Negative 5, still 0. Pi, still 0. No matter what number you choose, multiplying it by 0 always gives exactly the same result, 0. And that is the problem. There isn't a hidden number we fail to find. There isn't simply one. So no number satisfies this equation unknown times 0 equals 12. So unlike 12 divided by 3, which has exactly one answer, 12 divided by 0, and has no answer at all. The question is possible, but now another question appears. What about this? 0 divided by 0, at first it seems easier. We're asking what number multiplied by 0 equals 0. Well, let's test it. 1 times 0 equals 0. That works. But so does 2 times 0 equals 0, and 100 times 0 equals 0. Negative 7 also works. Pi still works. In fact, every single number works. Now, we have the opposite problem. Before, there were no answer. Now, there were infinitely many. And mathematics has no rule. A well-defined operation should produce one unique answer. Not 0 answers, not infinitely many answers, just one. That's exactly what happens with ordinary division. 12 divided by 3 has one answer, 25 divided by 5 has one answer, and 100 divided by 20 has one answer. But the moment a 0 enters the denominator, the certainty disappears. If the number isn't 0, there is no possible answer. So if the numerator is 0, there is too many answers. Either way, division loses the one thing mathematics depend on, uniqueness. And that is why mathematicians don't say we haven't figured it out yet. They say the operation is undefined. Not because the answer is hidden, not because it is difficult, but because the question itself stopped making mathematical sense. At this point, you might think, fine, if it doesn't have an answer, let's just invent one, as I am thinking. After all, mathematicians invent new numbers all the time. Negative numbers, imaginary numbers, even infinity appears in mathematics. So why not invent a value for division by 0? It sounds harmless, but in the next scene, we are going to try that exactly. And with just a few lines of algebra, we will accidentally prove that 0 equals 1. And once that happens, every number in mathematics becomes exactly the same. At this point, you might be thinking, who cares if there is no answer? Mathematicians invent new numbers all the time. Negative numbers were once considered impossible, so were irrational numbers. Every imaginary number sounded imaginary, so why not invent one more? Now let's pretend for a moment that dividing by 0 is allowed. Suppose there is some mysterious number, let's call that number x. And let's say 1 divided by 0 equals x. If division really is inverse of multiplication, then multiplying both sides by 0 should undo the division. So we get 1 equals x times 0. But wait, we already know something about multiplying by 0. No matter what x is, x times 0 is always 0. So our equation suddenly becomes 1 equals 0. Not almost, not approximately, exactly equal. We've just reached a contradiction. And here's the most terrifying part. Once 1 equals 0, mathematics doesn't just become a little wrong. It completely loses its meaning. Watch what happens. If 1 equals 0, then adding 1 to both sides, now you get 2 equals 1. Then add 1 again, 3 equals 2. Keep going, suddenly 4 equals 3, 100 and 99 and so on and so forth. Every number collapses into every other number. The distinction between them disappears. Imagine a ruler where every mark is exactly the same place, or a clock where every hour points to 12, or a keyboard where every key is typed the same letter. Those systems will become useless because they could no longer distinguish one thing from another. That is exactly what is happening to mathematics. Numbers only have meaning because they are different. The moment those differences disappear, so does arithmetic, so does algebra, so does equations. Nothing can be trusted anymore. But here is something even deeper. This isn't happening because 0 is evil. It is happening because we ask mathematics to do something impossible. We ask it to reverse an operation that had already erased all the information. And that is the real mystery, because multiplying by 0 doesn't just produce 0. It destroys something far more valuable. It destroys the ability to recover where you came from. And that pieces is what we've been missing all along. And in the next scene, we discover that multiplication by 0 is like a perfect shredder, once that destroys information so completely that no amount of division can bring it ever back. So far, it seems like 0 is the problem after all. It is the one number that refuses to cooperate. But 0 isn't really the villain here. The real problem is much deeper. Think about multiplication for a moment. If I tell you that 5 times 4 equals 20, you can actually work backwards. 20 divided by 4 gives 5. The original number is still recoverable. Nothing is lost. Now, watch what happens when 0 enters the picture. 5 times 0 equals 0, 0 times 0 equals 0, 1000 times 0 equals 0, pi times 0 equals 0. Completely different numbers produce exactly the same result. It is as if every part in mathematics suddenly leads to the same destination. Imagine writing 100 different books. Every book tells a different story, different character, different ending. Now imagine feeding every one of those books into a machine that shreds every page until all that is left is a single blank of sheet of paper. Once that happens, you could actually look at the blank page and tell which book it actually comes from. Of course not. The information is gone, not hidden, not encrypted, destroyed. That is exactly what multiplication by 0 does. It takes infinitely many numbers and maps every single one of them to exact the same output. 0. So now imagine asking division to reverse that process. It's like handing someone the blank page and saying, tell me the original book. There isn't enough information, and there never will be. Division can only reverse multiplication when multiplication leaves a unique trail behind. Multiplying by 3 leaves clues, multiplying by 10 leaves clues, but multiplying by 0 erases every clue. And once that clue is gone, there is nothing left for division to recover. This is why mathematician doesn't say division by 0 is difficult. They say it's undefined, because the information needed to define a unique answer no longer exists. And once you say it that way, something remarkable happens. 0 isn't refusing to answer our question. Our question is asking 0 to recover information that had already been erased. That is impossible, not because 0 is special, but because logic itself has limits. And that is why every calculator, every computer, every branch of mathematics agree on this same answer. Not because they were programmed to, but because there simply isn't enough information left to produce one. So why does 0 break everything? The answer is it doesn't. 0 doesn't break mathematics, it protects it. Throughout this video, it seems like 0 was the troublemaker. It erased numbers, it refused to divide, it led us to the contradiction that 1 equals 0. But none of that happened because 0 was behaving badly. 0 followed its own rule perfectly every single time. The real problem began when we asked mathematics to do something impossible. We ask division to recover information that multiplication by 0 has already erased. And once information is gone, there is no logical way to actually get it back. That is why division by 0 isn't forbidden because mathematician dislikes it. It is forbidden because there is no consistent answer that actually preserves the structure of mathematics. Without this rule, every equation could prove every other equation. Engineering would lose its certainty, computers couldn't trust their calculation. The mathematics behind GPS, spacecraft, artificial intelligence, and modern physics would all collapse under contradiction. In a strange way, zero acts like a guardian. It quietly stands at the edge of mathematics, protecting all questions that have no meaningful answers. Sometimes, the most important rule in a system is knowing what the system should refuse to do. And perhaps that is the most beautiful lesson zero has to teach us, because not every question deserves an answer. Some questions reveal the limit of the language we're using, and those limits are what keeps the entire structure standing. This tiny circle we call zero doesn't represent weakness, it represents consistency. It reminds us that mathematics isn't just about finding answers, it's about asking questions that actually make sense. So, next time your calculator flashes math error, remember it's not failing, it is protecting one of the most elegant logical systems humanity has ever created. If you like this, make sure you like and subscribe for more, and I hope to see you next time.